All right, so if you've ever actually tried to build with LLMs, you know this feeling, right? That massive gap between a cool little RAG prototype that works on your machine and a system that can actually survive in production? It's huge. Well, today we're going to bridge that gap. We're moving way beyond basic retrieval to build systems that don't just find documents, they genuinely understand them. Let's dig in.
So let's just start with the big, nagging question that keeps developers up at night. Why do most of these RAG systems fail silently in production? You know the drill. You build it, it works great on your perfectly clean test documents, but then you push it to production with thousands of real-world, messy files, and it just starts to break down. But it's sneaky, right? It doesn't crash. It just starts giving you terrible, irrelevant answers. So what's really going on here?
And this right here, this captures that disconnect perfectly. On the left, you've got the promise, the dream of RAG, right? You get answers from your own data. You reduce hallucinations. It's supposed to be amazing. But then there's the reality, what most of us actually get. We get results that are technically similar. Maybe they have the right keywords, but they're completely wrong in context. Or you get these fragmented, incomplete answers because the real meaning got totally shattered when you ingested the data. It's a brittle mess. And today, we're going to fix it.
Okay, so to actually fix this, we first have to get to the root of the problem. We need to diagnose what's actually causing these failures. So let's dive into RAG's promise and its biggest problem.
You know what's really fascinating is that most of the time, the problem isn't your fancy LLM. And it's not your super fast vector database either. No. The real culprit is the pipeline that's supposed to get the information ready for the model in the first place. It's the classic garbage in, garbage out scenario. Your information extraction pipeline is just too brittle.
All right, let's break down the first and, I'd argue, the most critical of these silent failures. It's something called semantic collapse. And this is all about that very first step, how we chop up our documents into chunks.
So just take a look at this one sentence. It's from a pretty standard HR document, right? But look at how much is packed in there. You've got a waiting period, you've got a specific definition for part-time employees, you have an exclusion for vision benefits, and an inclusion for medical coverage. All of that is connected. It's one complete thought, a single cohesive semantic unit. But now watch what happens when our naive just count the tokens chunker gets its hands on this. You can see it right here. Chunk A gets the part about medical, dental, and vision coverage. But the super important rule about part-time employees? Yeah, that gets sliced right off and ends up over in chunk B. That critical link between the benefit and the rule is just gone. It's severed. So now when a user asks, hey, can part-time employees get dental? The system might pull up chunk B, see nothing about dental, and just completely fail. The original meaning has totally collapsed.
And this whole problem of semantic collapse, well, it gets even worse. It's compounded by two other big failures that happen right at the very beginning, during the extraction process. So, failure number 2 is what we call content brittleness. I mean, think about it. Real-world PDFs are messy. They have tables, scanned images, charts, all sorts of stuff. A simple text extractor just ignores all of that and can easily miss 30, even 50% of the actual meaning. Then you have failure number 3, missing semantic context. Basically, every chunk becomes its own little island. You might have one chunk that talks about deductibles and another one that talks about out-of-pocket maximums. To a human, those are obviously connected, but to the system, they're total strangers.
So how in the world do we fix these deep structural problems? Well, the answer isn't some quick hack or a single magic trick. It's a much smarter, layered architecture. And that brings us to the solution, the Agentic RAG blueprint. Now, this blueprint is a complete multi-stage pipeline. It's designed specifically to fix every single failure point we just talked about. First, it starts with an intelligent analysis of the document itself. Then it moves to semantic chunking that actually respects the meaning. After that, it uses a really powerful dual embedding strategy. And here's the magic. It adds a game-changing agentic enrichment layer. And finally, it all goes into enriched storage that lets us do way smarter querying.
Okay, let's start where it all begins, the foundation. How do we get information into the system in the first place? This is all about smarter ingestion, because that's how we create smarter chunks right from the get-go.
So the key idea here is to have an adaptive pipeline. We have to stop using a one-size-fits-all approach. A smart framework will first analyze the document. You can see it right here. If it sees a scanned PDF, okay, it enables OCR and image description. But if it's a digital PDF, it's smart enough to disable OCR and just use the clean native text. It can even turn on other tools like formula enrichment. It intelligently picks the right tool for the job every single time.
Next up, embeddings. And here, the blueprint uses a dual strategy to get the best of both worlds. On one hand, you have dense embeddings. These are awesome at capturing semantic meaning. They're the ones that know doctor appointments and specialist visits are basically the same idea. Then, on the other hand, you have sparse embeddings. These are all about lexical importance. They're amazing at finding exact keywords, knowing that a specific term like $50 copay is absolutely critical. You really need both to get that perfect balance of precision and recall.
Okay, now we're getting to the real secret sauce of this whole blueprint. This is the core innovation. So once we have our smart chunks and our powerful dual embeddings, we add a layer of intelligence on top that just changes the entire game. And this is the agentic enrichment layer.
And we're not just talking about one little process running in the background here. No, the blueprint uses a team of 5 specialized LLM agents. They all work at the same time, in parallel, analyzing and adding this rich, structured metadata to every single chunk of data.
This table does a great job of showing you exactly what that means in practice. So for that one little piece of text about part-time employees, you have a summary agent that creates a quick, concise summary. Then, a semantic role agent comes in and figures out its purpose, tagging it as eligibility criteria. Then, an entity extraction agent dives in and pulls out structured data, like flagging part-time as a status. And just like that, our chunk of text is no longer just a blob of words. It's a structured, intelligent object that the system can actually understand and work with.
Okay, so we've done all this complex engineering. But so what? What does it actually get us? Well, let's look at the payoff. This is where the difference between the old way and this new way becomes crystal clear.
All right, here is a perfect example of a realistic user question. It's complex, it has multiple parts. The person is both part-time and has a chronic illness. A basic, naive RAG system is almost guaranteed to fail on this because it has no way to connect those two separate ideas into a single, coherent answer.
And here you go, the result. It's an absolute night and day difference. On the left, you see what the naive RAG system spits out, just a jumbled mess of disconnected fragments. Sure, it found the keywords part-time and chronic illness, but it has zero understanding of how they relate. But on the right, the Agentic RAG result is structured, it's contextual, and it's actually useful. It uses all that metadata we added to filter by the role, like eligibility, benefit descriptions, costs, and it gives you a synthesized, relevant answer. That right there is the difference between a cool demo toy and a real production-grade tool.
So let's wrap this all up with the key takeaways, the things you really need to remember. First, it all starts with chunking. Your entire system is built on a foundation of smart chunking that respects semantic boundaries. Second, that dual embedding strategy is absolutely crucial for getting both precision and recall. Third, that extra bit of latency for agentic enrichment, it is so worth it. It pays for itself over and over with better filtering and explainability. And finally, observability is just non-negotiable. You have to be able to catch these silent failures in production before your users do.
Ultimately, what we're talking about here is a fundamental shift in how we think about these systems. The goal isn't just to retrieve text that happens to match some keywords. The real goal is to build a system that can genuinely understand the content, the structure, and the relationships inside your documents. That is how you finally move from a fragile prototype to real, production-grade intelligence. I really hope this helps you go out and build better systems.